Let's look at a couple of specific examples. I'm going to show you a couple of different ways, starting with what should be very familiar from your chemistry course. Here's the conversion. 1,520 centimeters. We want to know how many kilometers that is. We're going to begin by writing the number we are starting with, including the units. I see a lot of students doing conversions without writing their units down. And what I ask them is, what's the point? The entire purpose of a conversion is to change units. The entire process is about units. If you're not including your units, you're not doing anything useful, so you may as well just stop. You must write down your units when you are doing conversions. You must write down your units at all times. We need to get rid of our centimeters, so we put it on the opposite side of the line so that they'll cancel out. We're going to have an intermediate step to go back to our base unit, but this isn't where we're going to end. We need to end with kilometers, so we need to get rid of meters. We're now going to go to our conversion factors. We know that 1 meter is 100 centimeters, and we know that 1 kilometer is 1,000 meters. We can now do some division. Dividing by 100, we're going to move our decimal point twice to the left. So 1, 2, there's my 100 taken care of. Now I have to divide by 1,000, so I'm going to move 3 more times. 1, 2, 3. And we find, to clean this up a little bit, that 1,520 centimeters is 0.01520 kilometers. This is probably not a conversion you're actually going to do, because that's a terrible number. We would much rather deal with 1,500 centimeters than this number of kilometers. However, the point is this methodology. So that's a very traditional way to do it. Here's option B. Option B is using the powers of 10. We're going to set it up basically the same way, except no intermediate step. I'm going to get rid of centimeters. I'm going to gain kilometers. I'm going to look at my bottom unit, see centi. I know that centi, looking back at my previous page, centi is 10 to the negative 2. So diagonal from there, I'm going to write 10 to the negative 2 there. Seems a little counterintuitive, but this works every time, promise. I look at kilo. Kilo means 1,000, which is 10 to the 3. I'm now ready to complete my conversion. I have 10 to the negative 2 divided by 10 to the third, which is to say 10 to the negative 5 kilometers. Writing this in proper scientific notation, 1.520. I've moved left 3 of those, so I still have 2 left over. This is using our exponent rules. We'll have to have another video on that some other day. So here's another way that you can set up these conversions. Let's look at another example. 28.4 megagrams to milligrams. This is again not an actual conversion you would probably ever have cause to do, but it's not the conversion that matters, it's the methodology. We have 28.4 megagrams. We're going to look at sort of a third way to write this out. Just find whatever's comfortable with you and make it work. Instead of writing out this long bar, what we're really doing is multiplying by conversion factors. I'm going to go from megagrams to grams, and then I'm going to go from grams to milligrams. I know that 1 megagram is 10 to the 6 grams, a million. I know that 1 gram is 1,000 milligrams. I'm now ready to do the conversion. The megagrams cancels, the grams cancel, and we're left with 28.4 times 10 to the 9 milligrams, putting it in proper scientific notation. I've moved to the left once, so I need to add another one up there, 10 to the 10 milligrams.